Hey guys, and welcome back. Today we are going to be finishing up our intro unit by talking about dimensional analysis. Now that word might sound a little bit intimidating, but all it is a fancy word for unit conversion. So we're going to be converting units today, and I promise it sounds a lot worse than it actually is. So we're going to go ahead and jump into it. And before we get into actually talking about dimensional analysis, I just wanted to give you guys a really quick refresher on graphing, especially since we just wrapped up with scientific method at the end of last week. So just a reminder, we use graphs to help us organize and display our data. And I just wanted to remind you guys of when you're looking at a graph of how to identify where your independent and your dependent variable are. So when we're looking at a graph, like for example here we have a bar graph, your independent variable always goes on your x-axis, and the x is the horizontal, so the one on the bottom that goes from left to right. So the independent variable, so the thing that you manipulate about the experiment, always goes on the x. The dependent variable, or what you measure in the experiment, always goes on the y, and the y-axis is that vertical axis, so the one that goes up and down. So that was just a little refresher about graphing. We'll probably look at, well, we definitely will look at graphs throughout this semester in this course, so I just wanted to give you a quick refresher. And of course, as those different types of graphs pop up, we'll go over them individually as well. So let's go ahead and talk about dimensional analysis. So before we can even start with the math portion of what we're doing today, we have to first understand that there are 7 base units that we're going to look at that we're going to have to be able to basically convert between. So there's 7 base SI units, but we only need to know 5 of them for chemistry. And they're based on an object or an event in the physical world, and they are independent of other units. Now, when I say SI units, that's just the International Standard Unit. Here in America, for whatever reason, we use like feet and inches, whereas the rest of the world uses the metric system. So to keep things even across the playing field in science, we use the metric system. So basically, SI units, or the International System of Units, is a fancy way of saying metric system. So here are our base units that we're going to be taking a look at today. So if we needed to measure something at time, we would use seconds. For length, we would use meter. For mass, we would use gram. Temperature is Kelvin, and the amount of a substance will be in moles. Now, we don't have to worry about moles today because moles will come a little bit later on. Today we're just going to be focusing on the other base units. This is a metric conversion chart, and I'm going to teach you the mathematical way to convert today, but this is also a helpful cheat sheet if you needed to do like a really quick conversion. And this just shows you how you can convert between a base unit by moving the decimal place, because that's really all we're going to do here. So if we take a look at this, our base unit is in the middle. The base unit is going to be these, right? So seconds, meters, grams, that's what's in the middle, okay? Then we have these prefixes that tell us how many of that unit are present. So kilo is 1,000, hecto is 100, deca is 10, deci is a tenth, centi is 100th, and milli is 1,000th. So if you wanted to convert between those bases, you could literally just take a look at the base in the middle, decide which direction you want to go in, and then move your decimal point over. So if you move from the middle to the left, you would move your decimal point to the left. And if you move to the right, you would move your decimal point to the right. So let's use a meter as an example. So let's say we start with a meter, and we want to know how many centimeters are in 1 meter. Well, if we go from our basic unit, we would go to the right 1, 2 to get to our centimeter. So we would move our decimal place, because we moved to the right 2, we would move our decimal place to the right 2 as well. So if we had our imaginary 1 with our decimal point right here, we would move it over 1, 2, and you would fill in your zeros, so you would have 100. So we would know there's 100 centimeters in 1 meter. Okay, so that's how you can figure out your conversions. Also, there's this little mnemonic here to help you remember these. So King Henry died by drinking chocolate milk. So each of the first letters in this mnemonic coincides with each of the units. Okay, and then of course the B in the middle. So King Henry died by, the B stands for the base unit. Okay, and again, those bases are these units right here. Okay. So temperature is a little bit different. So temperatures, it's not on the metric system and like perfect 10, 100, 1,000. So when we use temperature, again, the SI unit is Kelvin. On the Kelvin scale, water freezes at 273 Kelvin and boils at 373 Kelvin. So we're dealing with larger numbers than like on our 32 degrees Fahrenheit. So remember, when we use Fahrenheit, 32 degrees is the freezing point of water. Celsius scale, the freezing point 0 and the boiling point is 100. So if we needed to convert between Kelvin, Fahrenheit, Celsius, this would be basically a simple addition or a subtraction problem. So to go from Celsius to Kelvin, you would take your degrees Celsius and you would add 273. So an example here, it says the element mercury melts at negative 39 degrees Celsius and boils at 357 degrees Celsius. Convert these temperatures to Kelvin. So here, just to do that conversion, you would just have to add 273. So the melting point of mercury, negative 39 plus 273, would give us 234 Kelvin. And then the boiling point of mercury, 357 degrees Celsius plus 273, would give us 630 Kelvin. Okay, most times you guys would probably be converting between Celsius and Kelvin versus Fahrenheit because, again, Fahrenheit is an American thing and we're going to be focusing on using the metric system. So the base units that we saw previously are, again, just base standard units, but some quantities have to have something called a derived unit. And a derived unit is just a combination of base units. So like, for example, if we're measuring speed, that would be in meters per second. And that's something you would deal more with in like physics if you go on to physics. But meters per second, that's a derived unit. And the easy way to tell, is it a base or a derived unit? If it's a derived unit, it's going to have more than one unit in it. So meters is a base unit. Second is a base unit. Meters per second, because there's two base units there, that's a derived unit. Okay. Other quantities that are measured in derived units are volume and density. Density is mass per volume, and then volume is typically per area, so that's going to be in a derived unit. All right, so how do we do the conversions without moving the decimal places? So I showed you guys that metric chart and showed you how to move it based on just moving the decimal, but that's not going to do us much good when it comes to calculating moles in the future, so we want to know how to set it up mathematically. So this is just a method that we're going to use that focuses on moving between these units. And to do this, we're going to have to use something called a conversion factor. This is going to be a ratio of equivalent values used to express the same quantity in different units. And the conversion factor is always equal to 1. So 1 of something will equal X quantity of something else. So let's take a look. So to do this, we're going to use a T-chart, and it's just called a T-chart because it looks like a T, right? So here's our T. So we're always going to start on the left-hand side of our T-chart with what we're given. And then on the right-hand side, there's always going to be some conversion factor that we're going to use. And remember, the conversion factor is always set equal to 1. 1 of something is equal to an X amount of something else. So let's take a look at an example. How many meters are in 48 kilometers? Well, this is something we can solve using dimensional analysis, but we first have to make sure we have our conversion factor, okay? Now, we're starting with what we know, right? That's the first thing you want to put on the left-hand side of your T-chart. We know that we're starting with 48 kilometers. So we start with 48 kilometers on the left-hand side. On the right-hand side, we know we want to convert to meters, right? Because we want to know how many meters are in 48 kilometers. So we're going to put our meters on the top, and we're going to put our kilometers on the bottom here, okay? So a really good way that I always remember this is whatever you want to get rid of, it needs to be in the opposite position. So we start here, if you can visualize this as a like a fraction. Here in the numerator we have kilometers, so we know when we do our conversion we want our kilometers in the denominator on the right hand side because we want these kilometers to equal out or cancel each other out so that we're only left with the meters, okay? So we have our meters on the top and our kilometers on the bottom. Now, we have to figure out what our conversion factor is. So we've got our 1 on the bottom, and we're going to put the 1 with the kilometer because the kilometer is larger. So 1 kilometer, and then we need to put the 1,000 with the meters because that's our conversion factor. So for every 1 kilometer, there are 1,000 meters, okay? And again, that goes back to that chart that we saw earlier on that showed us the units and how many of each were related to the base unit. So for every 1,000 meters, there's 1 kilometer, or alternatively, you could say for every 1 kilometer, there's 1,000 meters. The biggest thing you want to do is make sure the correct number goes with the correct unit, right? It doesn't matter where it is in the numerator or the denominator. Like if we were to flip this, like if we were converting 2 kilometers and we needed the kilometer in the numerator and the meter on the bottom, doesn't matter. The 1,000 always goes with the meter, and the 1 would always go with the kilometer for this conversion factor. So then you just set it up like a normal math problem. So here the kilometers would cancel. So it would be 48 times 1,000 all over 1. Okay? And so all we have to do would be to punch in our calculator, 1,000 times 48, and that would give us 48,000. So 48 kilometers would be equal to 48,000 meters, okay? All right, let's look at one more practice problem, and of course I'll be doing some more of these in class and making a separate video where I work these by hand as well. So Mount Everest is 8,847 centimeters high. How many centimeters high is the mountain? I think this is supposed to say meters because it gave us centimeters. This should be meters. So ignore the centi here. We're starting with centimeters. We want to know how many meters high. So again, on our left-hand side of our T-chart, we're going to start with what we know, which is that the mountain is 8,847 centimeters, right? Now we're going to set up our conversion factor. So centimeters is in the top over here. So the first thing I would do is write my centimeters in the bottom because I know I want those units to cancel. The unit I know I want to be left with is meters. Remember, we're ignoring the cent here. We're just doing meters. So I'm going to put my meters on the top, okay? Now we have to have our conversion factor. And I know, based on that conversion chart we saw earlier on, for every 1 meter, there's 100 centimeters, okay? So then if I solve this as a math problem, 8,847 times 1 divided by 100 is going to give us 88.47 meters. So we would say Mount Everest is 88.47 meters tall. Okay? Now, it's a little bit hard, especially if you're not a math person, to visualize this just being on a slideshow. So be on the lookout because I'm going to make a separate video of me working these step by step by hand, and that will help us as well. So if you're struggling or anything, of course, let me know. But for now, this is where we're going to end this today.